Section 1.3 is some more information about segments. Okay. First of all, if I have segment AB, okay, if I want to talk about segment AB, I'm going to say this. That means segment AB, and we've talked about that before. This is an important distinction. If I just say AB with no symbol above, that means the length of AB. Okay? This is a figure. This is a number. And that's important. Okay? It's a very important distinction that's going to be with us all the way through this course. You need to get it through your head that this is a figure and this is a number. That's going to be important all the way until the end of the course. Okay, a couple of terminology things before we get into the meat and potatoes of today's lesson. In geometry, we're going to have two big ideas. One is a theorem, and one is the idea of a postulate. A postulate is something we just accept as true. It's usually really obvious. It's something like the length of something is how long it is. It's often just something really goofy. That's what a postulate is. A theorem, sometimes obvious, but a theorem can be proven. And is generally less obvious. Can be pretty, like I said, can be pretty obvious. But there's usually a little more to it. Okay, so a postulate we just accept as truth. It's sort of like a given. It's sort of an assumption. A theorem is something we know is true based on our postulates. Theorems are usually derivative. You start with a postulate and then you can get some different theorems. Alright. One quick other thing before we get to our first postulate that we'll study this year, first important one, is the idea of between. Mathematically between. If I have points A and B, colloquially, if we have point C down here, we might say, yeah, C is between A and B. That makes sense. Mathematically, no. Mathematically, between means on the line between the 2 points. It's not just kind of in the middle. Point D is between A and B. It's collinear and between. Now, I just use the word between to define between, but you get the idea. It's got to be on the line connecting the points for it to be between 2 points. It doesn't matter where. It could be over here, over here. We don't care. But that's what between means mathematically. Alright, our first big postulate is the segment addition postulate, which we will often abbreviate SAP. The segment addition postulate says that if we have two segments, A, B, and C, and they're collinear, that if I'm going to do with numbers first, and then we'll do the general case. If this is 6 and this is 3, how much is the whole thing? If AB is 6 and BC is 3, how much is AC? Well, obviously, it's 9. How do we know that? We added the segments. This is the segment addition postulate. So the segment addition postulate actually says if B is between A and C, which we see that it is, that we can do AB plus BC equals AC. We can add up the two parts, and it's equal to the whole thing. That's the segment addition postulate. This one's going to be with us for several chapters here to come. The segment addition postulate says we can add two segments, and it equals the whole thing. Quick quasi-example here. Okay, we'll pretend that's linear, that's straight. So if I DEF, and maybe I told you that this was 3x plus 2, this was 9x minus 7, and I said DF is 43. Well, if we wanted to solve for x, we could just take DE plus EF and set it equal to DF. So we could take 3x plus 2 plus 9x minus 7 and set it equal to 43. That's the segment addition postulate. Okay? It's just plugging in. It's basically taking this and we plug in the parts. This is here, this is here, and this is here. Okay, simple idea. This next topic here is something that's kind of just thrown in because we need to talk about it sometime, and it sort of fits with what's going on in this section. It's the distance formula, which you may have seen before. This is one of those things that students convince themselves is difficult, but it's not. Okay, the distance formula says if we have 2 points on the coordinate grid, x1, y1, and x2, y2, that we can find the distance between those 2 points, d, by saying this: square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, and students always tell me that this is hard, and I always ask, okay, what's the hard part? Is it the subtraction? Is it the addition? Is it the squaring a number? Or is it taking the square root? And generally, it's the taking the square root that people get mad about. My advice is get over it. Okay, I do expect that you can simplify radicals. If you don't, if you have trouble with that, I'm going to post a link to a video that talks about it in a little bit more depth. It's not one that I made, but I'm going to link you to an off-site one. Basically, I'll just do one quick example, hopefully jog your memory. If I have square root of 27, that's the same as square root of 9 times square root of 3. Square root of 9 simplifies, so we can write 3 square root of 3. So when you're doing distance formula and plugging in, this is the sort of thing I want you to do. Right, and if it comes out even, great. If it doesn't come out even, then I probably want you to leave it in radical form, or sometimes I may say to put it in decimal form. I may say both. So we'll discuss how to put it in radical form on the computer. And here's how. To get the radical symbol to show up, you press the Alt button and then 251. And then you release the Alt button. So you're going to press Alt, type 251 while holding Alt, and then release Alt, and it will make a square root symbol. And it'll actually kind of look like, if you were doing 3 root 3, it would look like this. But that'll be sufficient. The computer will know what you're talking about. All right. If you need help with this, if you're just overwhelmed with distance formula, we'll give you some individual help. But I think most of you can just plug into a formula. I mean, if you had something like 2, 3, and negative 3, 6, we can just plug those numbers in to the right places and do arithmetic and figure this out. So that's the distance formula. I'm not going to talk any more about it. Last topic for right now, for this section, is the idea of congruent segments. This is sort of the definition of congruent segments. What does congruent mean? Congruent means the same size and shape, basically. So if I say that segment AB has the same length as segment DE, well, segments don't really have a shape. They're all the same shape. But if I say that their lengths are the same, then that's the size. And there's one way that we can always show that two things have the same length, and that's with a little mark across it like that. That mark means congruent. It also means the same length. So if the lengths are the same, we can also say this. Segment AB is congruent to segment DE. Okay, this says this is talking about lengths, like we talked about earlier. This is talking about segments. This is another important distinction. Lengths are equal. Segments are congruent. This is the congruent symbol. It reads is congruent to. And we'll be using that throughout the course. We'll be talking about congruent stuff all the way through the course. And that's it for section 3. A little bit more to this section. You might have to spend a little bit more time working through the problems, but hopefully it won't be that bad.